Hey guys, welcome back to my channel. Today we are going to go over the homework answers from lesson 2C-1, day 1. Alright, so for each equation below, 2y equals negative 6x plus 4 and y minus 6 equals x, we're going to have to solve this. So it's kind of breaking everything down into steps for us. So our first step is to get it in y equals mx plus b form. Now forgive me, I just need to make this a little bit bigger so I'm not so sloppy. Okay, so here, I want to isolate the y, so I'm going to divide everything by 2. So 2 cancels out, so you're left with y is equal to negative 3x plus 2. That's your first one. Now over here, y wants to be by itself, so I just have to add the 6 to the other side. Now remember, x and 6 are not like terms, so we just write it like x plus 6. They cannot be combined. So these are our two equations. Now we want to get a table, all right, for both of these. So you can easily put these in the calc and go to y equals, all right. So y equals, you're going to enter this, and then hit second graph to look at the table of values for each of these. So in a second, I'm just going to fill all of these in for us. Okay, so this should be your table of values for y equals negative 3x plus 2. Keep in mind that our y values, they decrease by 3. And the pattern continues, while our x values continue to increase by 1. All right, so remember, that's always going to happen as long as your x's are incremented by 1. Your rate of change in your y should also match your slope. So remember, this is a constant rate of change, so we know it's linear. All right, so now for the other one. This is our table of values. 3, 2, 1. So this should be your y column. And we can also see that in my y column, I'm going up by 1 constantly, as well as my x. So that's why my slope is 1. All right, so that's your table of values. I hope you guys are okay putting that in the calculator. Now, here's the important part. Circle the point that is in both tables. So let's examine that carefully. The point that appears in both tables is negative 1, 5 appears in both tables. Negative 1, 5. So if negative 1, 5 is a point that appears on both tables for each linear function, that means that when I substitute in my value of x and y, all right, that's going to be the same. It's going to create a true equation. So here, I'm going to plug in negative 1 for x and 5 for y. So I know I have 2 times something equals negative 6 times x plus 4. So I'm going to plug in y over here, so that's 5. Negative 1 goes over here. And I want to see if this is a true statement. That's why I put my little question mark thing over here. So is 10 equal to negative 6 times negative 1? That's going to be positive 6. Positive 6 plus 4. Is 10 equal to 10? Yes, it is. So we know at least this point will show up for this equation right here. All right. Now remember, you always plug into the original. So now I'm going to have x, same old thing. X is negative 1, y is 5. I have y minus 6 is equal to x. I'm plugging in 5 for y and negative 1 for x. So 5 minus 6 is negative 1, and that is equal to negative 1. So yes, negative 1 comma 5 is a solution to both equations. We've proved it algebraically, and you can also tell by the table of values, since the point is on both, that we are good. In the table of values that both tables have negative 1 comma 5. When we algebraically plugged it in, you saw that when I plug in negative 1 for x and 5 for y, we get a true equation. 10 equals 10 on this side of town. Oh my goodness. Yeah, and then we get negative 1 equals negative 1 on that side of town. All right, now over on this side of town, flip the page for the system of equations below, graph both lines and see where the point of intersection is. Same old lines. We already did this before, so just copy it over. Y equals negative 3x plus 2 and y equals x plus 6. Let me just make sure that that's right. Yup, it's good. So, graph each equation one at a time. You can either use the table from the calculator or slope-intercept method. I always like slope-intercept method. That's just the way I roll. But, you know, you can do whatever you want. All right, so I copied my equations down. My slope here is going to be negative 3 over 1, which means we're going down 3, right 1, and I'm going to start at 2. So let's do that. We're going to start at 2, and we're going to go down 3 over 1. I know that's beautiful. It's really beautiful. Almost brings a tear to your eye, how beautiful that line is. Okay, the next one over here, we have a slope of 1 over 1. That means we're going to go up 1, right 1, and we're starting at a y value of 6. So we have this. And then we're going to go up 1 over 1, up 1 over 1. Whoop, there it is. There's that point of intersection. Oh, I missed it a little bit, but you get the point. It's right there at negative 1 comma 5. So I think you guys are getting the point here. Obviously, we are graphing them, and we're still seeing the same point coming up again. Negative 1 comma 5 is the intersection point, and we've proved it. And honestly, guys, we did this before, so I'm just going to copy over what I had on the previous page. Right, I just copied the original and I plugged in negative 1 for x and 5 for y. Does 10 equal 6 plus 4? It sure does. So I just plugged it in. 5 minus 6 is negative 1. So obviously negative 1 equals negative 1. So guys, it's the same thing. This was an intro to what we did today, and I hope this helped you. So yeah, have a good one.